Hello once again, this is Teacher King David. We're still on the revision questions about complex numbers. We're up on number 25. So number 25 is saying, solve the equation in the complex number set in the system in R power 2, in R squared. So we have Z power 4 minus into bracket 8I minus 1, Z squared minus I equal to 0. We're going to solve that equation. We have 25, number 25, where the system of equation is Z power 4 minus into bracket 8I minus 1, Z squared, then minus 8I equal to 0. So this is what we call biquadratic equation. When it is biquadratic equation like this, what you do, we just let, because you see we have Z power 4 and Z squared, we let Z power 2 to be equal to T. Let Z squared to be equal to T. So if Z squared is T, it means that where there is Z power 4, we're going to have T squared. So it will be T squared minus 8I minus 1 into bracket T minus 8I equal to 0. So now you see our equation now, it is quadratic equation. We're going to use to solve quadratic equation by using quadratic formula. So where our A, coefficient of T squared is 1, B, coefficient of T, it is negative into bracket 8I minus 1. Then the constant C is negative 8I. So use quadratic formula, which is T equal to negative B plus or minus B squared minus 4AC divided by 2A. After getting the value of T, it will help us to get Z squared. So now, our T is negative becomes positive. It will be 8I minus 1 plus or minus square root of this value squared. And when this value is squared, this negative becomes positive. It will be 8I minus 1 squared. 8I minus 1 squared. Then minus 4. Our A is 1. Our C is negative 8I. Divided by 2 times A, which is 1, which is 2. So our T will be equal to 8I minus 1 plus or minus. We're going to expand this one. And you know when you have like A minus B squared, the answer is A squared minus 2AB plus B squared. That's what we're going to use. So it will be A squared, which is 8I squared. That is 64I squared. And I squared is negative 1. That's negative 64. Minus 2AB. Minus 2AB. So 2, our A is 8I, our B is 1. So then that is 16I. Then plus B squared plus 1. Divided by 2. So then T will be equal to 8I minus 1 plus or minus square root of negative 64 plus 1, that's negative 63. Plus 16I. Divided by 2. So you see, we have square root of this one. We're going to first find the square root of that one. We first find square root of negative 63 plus 16I. So we're going to find the square root of that one. You remember the way we find the square root of this one, we use 3 equations where x squared minus y squared equal to A, 2xy equal to B, x squared plus y squared equal to root A squared plus B squared. I think you remember this one from the notes. So now, our A here is negative 63. Our B is 16. A is this one, B is this one. So now, which means that x squared minus y squared equal to negative 63. 2xy equal to b, which is 16. Then x squared plus y squared will be equal to square root of negative 63 squared plus 16 squared. So finally, it is x squared minus y squared equal to negative 63. Then 2xy equal to 16. Then x squared plus y squared equal to, if you use calculator, square root of this one is 65. So, which means that we have two equations. We have x squared minus y squared equal to negative 63. I'm going to use this first equation and the third equation. Then x squared plus y squared will be equal to 65. We add to eliminate y squared. So 2x squared will be equal to 2. So x squared will be equal to 1. So our x will be 1. We can use plus or minus, but no need of using plus or minus because our plus or minus is here. So then x equal to 1. Then if x equal to 1, what will be the value of y? From 2xy equal to 16, if x is 1, 2y will be equal to 16. So y will be equal to 8. So meaning that the square root of 64 minus 63 plus 16i is x plus yi. Our x is 1 plus 8i. So after getting the square root of this one, we are going to find the value of t. Then now, the square root of negative 63 plus 16i is 1 plus 8i. So meaning that t will be equal to 8i minus 1 plus or minus the square root of this one. And the square root of that one is 1 plus 8i divided by 2. So t has two values because it will be plus or minus. When you use plus, it will be 8i minus 1 plus 1 plus 8i divided by 2. So which is 8i plus 8i, this is 16i divided by 2, because this negative 1 plus 1 is 0, this is 8i. Our t1 is 8i. So if we use minus, it will be 8i minus 1, then minus 1 minus 8i. Because this is negative, we will change each and everything here to be minus 1 minus 8i divided by 2. So here, 8i minus 8i is 0, negative 1 minus 1, that's negative 2, divided by 2 equal to negative 1. So meaning that our t1 will be equal to 8i, and t2 will be equal to negative 1. Those are the values of t. Then from there, remember we have said that z squared equal to t. I'm going to say for t equal to 8i, what will be the value of z squared? So z squared will be equal to 8i. So which means that z will be equal to square root of what? Our z will be plus or minus 8i. So it means that we're going also to find the square root of what? 8i. So what we do, we use those three equations: x squared minus y squared equal to a, 2xy equal to b, x squared plus y squared equal to root a squared plus b squared. So here our a is 0, our b is 8, because you have 0 plus 8i. So now x squared minus y squared will be equal to 0, 2xy will be equal to 8, x squared plus y squared will be equal to square root of 0 squared plus 8 squared. Then finally, x squared minus y squared equal to 0, 2xy equal to 8. X squared plus y squared will be equal to 8 because 8 squared is 8. 8 squared then square root, the answer is 8. So we're going to use equation 1 and equation 2. I mean equation 1 and equation 3. X squared minus y squared equal to 0. Then x squared plus y squared equal to 8. We add to eliminate y. So this is 2x squared, which is 8. So x squared equal to 4. We find the square root. Then x will be what? 2. No need of using plus or minus because it is already here. So if x is 2, what is the value of y? From 2xy equal to 8 and x is 2, 4y equal to 8. So our y is 2. So meaning that for x equal to 2, even y is what? 2. Therefore z will be equal to plus or minus square root of 8i is 2 plus 2i. So therefore, our z1 is negative 2 minus 2i. z2 is 2 plus 2i. So those are 2. We're meaning with other 2. Then for t equal to negative 1. So remember, z squared equal to t. So z squared will be equal to negative 1. If we find the square root, our z will be equal to root of negative 1. Our z, you know that negative 1 is I squared. So our z will be plus or minus I. Because negative 1 is I squared, square root of I squared is I. So it will be plus or minus I. So which means that our set contains, this is z3, which is negative I, z4, which is I. So our set, it contains 4 roots, which are negative 2 minus 2i, 2 plus 2i, negative I, and I. So that is our set. It contains negative 2 minus 2i, 2 plus 2i, negative I and I, which is Z1, Z2, Z3, Z4. That's the solution set. I hope you don't have any question here. The answers are very clear. Thank you for understanding this one. Let's go to number 26. So let us proceed. We are on number 26. Number 26a is saying, show that z equal to 4 is the root of the equation, this one. So z equal to 4 is a root of z power 3 minus 3z squared minus 3z minus 4 equal to 0 if it is a zero of z power 3 minus 3z squared minus 3z minus 4 equal to 0. So what does it mean? If you where there is z, it is a zero of this equation if we use z equal to 4 and you get z equal to 0. So for example, where there is z, you're going to put there 4. 4 power 3 minus 3 into bracket 4 squared minus 3 into bracket 4 minus 4 equal to what? Is it equal to 0? So 4 power 3, that is 64 minus 16 times 3, that is 48 minus 12 minus 4. What is the answer? It is 64 minus 50, 64, which is equal to 0. So since 0 equal to 0, it means that is to say for z equal to 4 is a root. That's what it means. Our z equal to 4 is what? Is a root. So we are done with A. B. Find B is saying find all complex solutions of this one. We're going to find all complex solutions of this equation. And remember, we have seen that z equal to 4 is one of the root. So we're going to use synthetic division to get other roots. Let us use synthetic division to get other roots. So this is z. We have the root, its root, which is equal to 4. So this is a polynomial. Its coefficient here is 1. Its coefficient here is negative 3. Its coefficient here is negative 3. And the constant is negative 4. So this is 1. 1 times 4, this is 4. We add 1. 1 times 4, that is 4. We add, we get 1. 1 times 4, that's 4. Here we get 0. So meaning that we have another equation, which is quadratic equation, that is z squared plus z plus 1 equal to 0. So we're going to solve this equation to get other roots. Our a here is 1, our b is 1, our c also is 1. So we use quadratic formula, which is z equal to negative b plus or minus b squared minus 4ac divided by 2a. So our z will be negative 1 plus or minus root 1 minus 4 divided by 2. So our z will be equal to negative 1 plus or minus root negative 3 divided by 2. So our z will be equal to negative 1 plus or minus root 3i squared. I told you that negative 1 is I squared over 2. So then z2 will be equal to negative 1 over 2 plus I root 3 over 2. z3 will be negative 1 over 2 minus I root 3 over 2. So what have I done? Negative 1 over 2, I squared, square root of I squared is I. That's plus I root 3 over 2, negative 1 minus I root 3 over 2, which is this one. So then our set, it will be, we have the first root, which is 4. We have negative 1 over 2 minus I root 3 over 2. We have negative 1 over 2 plus I root 3 over 2. So we are done with number 26. I hope you are getting it. So let us go to number 27.